Three-factor ANOVA takes the concepts and rules of one-factor ANOVA and a two-factor ANOVA and adds the third variable or factor, as seen in this very simple diagram. While this diagram makes three-factor ANOVA look simple, it is way more complex than a two-factor ANOVA, as you are adding a third factor and another subset of levels under that. It's important to note that typically the factor levels are split into multiple categories as seen here, such as age with a column for under 18, 19 to 21, 21 to 25, etc. These areas should be used to fit your said data set and support what conclusion or hypothesis you're testing against. I really like this square image that I found on one of my website sources. It really visualizes what's going on in a three-factor ANOVA and what hypotheses and conclusions you can come to with a said three-factor ANOVA. Since three-factor ANOVA is a step above a two-factor, you would assume that, yes, it would use more sums of squares, and typically three-factor ANOVAs are calculated using programs. Separating your levels into categories also helps your clutter, but typically you're going to use a program to calculate a three-factor ANOVA because it's an absurd amount of numbers, especially if you're testing stuff like engineering piping, stuff like testing hypotheses that have data that with big numbers or floating point values and stuff like that. A three-factor ANOVA actually tests 7 different null hypotheses and reports 7 p-values. Depending on the outcomes of these, those null hypotheses have interactions with each other and really tell you whether or not they lead you to some conclusion about these hypotheses, and you can do with that information what you want to test more. For my example of a three-factor ANOVA, I just also have this little data set right by the image that I selected from one of my sources. It's randomized numbers. It's just trying to show how it would work with certain numbers. I chose the example of, let's say you have materials on a rocket, weight of fuel, speed traveled, and how these affect the boosters on a typical mission. And I think a three-factor ANOVA is a great way to determine whether or not, there's many hypotheses you can come up with, whether or not it's safe to launch, whether or not you can launch with certain materials and certain fuel weights. I think a three-factor ANOVA with many different versions of these weights, speed, and materials is a great way to estimate whether or not there's going to be a failure of some kind in this mission. And that's basically the gist of a three-factor ANOVA.